Okay, before I start my presentation about the PCI Passthrough, I wanted to ask your help. I'm honored to join the board of FreeBSD Foundation. We want to promote BSD in China. Firstly, we need to identify who is using BSD, who is planning BSD, or developing BSD in China. So we plan to organize two BSD meetup in China, one at Shanghai and one at Beijing. We also invited George visited Beijing. He will be there to deliver a talk face-to-face. And we also invited Robert to deliver a topic through audio conference like that. So, but the problem is, I already got Microsoft cover, the dinner cover, the gifts. However, we still need people. So I ask for your help. If you know somebody who is planning BSD in China, or you know any channel, could you please share this page to them, this link to them? I appreciate it. Thank you. Okay, 3 p.m. So let us start. Okay, firstly, I would like to thank Ecosystem to organize such a big and wonderful event, MeetBSD here, and giving us an opportunity to deliver a topic about our work on FreeBSD virtual machine. This work, in fact, is almost done by our developer, Dexuan and Sifi. So that is why I was so get Dexuan online to join this session. Not sure whether Dexuan you can hear me. If yes, maybe you could say hi to everybody.
Hi everybody, this is Dexuan from Shanghai.
Okay. Wow.
Well, thank you.
Okay, so I'm Kylie. I'm not a developer. I'm the PM, standing behind our developers and asking them where we are. Can we get it more faster? When could we deliver that? So that is my role. I mean, we are from Microsoft open source group. Yes, that's true. We are doing open source in Microsoft. Okay, today, before I go to introduce the PCI Passthrough, I would like give you a glance about Hyper-V architecture first, and then I will introduce PCI Passthrough and how we get it work in FreeBSD, and I will show a demo with FreeBSD virtual machine. Talk about our plan. Lastly, I also would like to show you some progress about the PCI pass-through cases in Microsoft Azure. Okay, firstly, to run virtual machine guest OS on Hyper-V, you need to get Intel x86 or MD64, and of course, Hyper-V, as a hypervisor, it also emulated devices, so you can directly run your OS on Hyper-V. However, functionality or performance and integration, those are poor. So we also need to have parallel virtual I/O virtualization. So to have that, we need to have virtual device drivers. Here, as for the virtual device exposed by Hyper-V, we call it as synthetic devices. And as for the devices we wrote for those virtual devices, we call it as integration service. Okay. This is the high-level architecture about Hyper-V. Here I use the FreeBSD VM as an example. I would like to give you some concepts. Maybe we will talk in the later. VM bus, VSP, and VSC. VM bus is an intercommunication channel between VSC and VSP. VSC that is in the virtual machine. Virtual machine hosts the VSC, we call it as virtualization service client, that redirect IO request to the host. Okay, then host the VSP, virtualization service provider, to handle IO request from the guest. So those are those. In FreeBSD virtual machines, we have drivers for VM bus, and we have drivers for storage and networking. You could see we named it as storage with C and network with C. And if you go to FreeBSD head, you could get our source code. And since FreeBSD 10, all of FreeBSD integration service is built in. Okay, you get those concepts. Let us introduce PCI Passthrough. We call it a discrete device alignment. This feature is available in Microsoft Windows Server 2016. And it allows, of course, the physical PCIe device can be directly accessed and controlled by the guest. And as for the PCIe device, it could be GPU, could be NVMe device, or networking adapter. Today, we will use the networking adapter as an example in the demo. To run it, we have some requirements for the system. For processor, chipset, and firmware. Of course, firstly, you need to mapping DMA between the physical and the virtual machine. So DMA remapping, you need that. And you also need the translation between host and guest about memory. So IOMMU is needed. And you also need a translation table between the host physical address and the virtual machine's address. So EPT or MPT is needed. Here, I also would like to highlight one thing, ACS. According to PCI Express specification, it optionally allows the traffic, all of the traffic of a device can be forced to up to the IOMMU. That is to to prevent data corruption. And the Hyper-V will check that and to ensure that this PCI device have this capability allowed. We do that wanted to ensure your virtual machine will not be impacted by others in the same machine. Okay, so that's requirement for the host. As for the device, not all of the device can be directly assigned to the guest, such as some older PCI style logic devices. So we also have a script to identify which devices can be assigned. It will check an IOMMU and whether your host is 2016 and check interrupt, check ACS. I will show that script to you later. Okay, so after talking about the requirement, let us see how to that work for the guest. We know some different hypervisors, virtualization platforms, they have different mechanism. For Zen HVM and KVM, they fully emulated PCIe bus. So for the guest, you need not do anything. You already could get PCIe device pass-through. However, for such a design, you need to do much work in hypervisor. You need to emulate PCIe bus. You also need to support firmware such as PCI BIOS. Then for Hyper-V, was similar to Zen PV guest. They did not fully, but just partially emulate PCIe bus. So for this part, no much work for hypervisor, but we need additional device driver, virtual device driver in virtual machine. That is how we do. When we do that, let me also explain about the trend. On Hyper-V since Windows Server 2012, we have two types of virtual machines, Generation 1 and Generation 2. The goal of Generation 2 VM is to simplify the firmware support and remove some legacy device emulation. It also including PCI bus. So that's the trend. Hyper-V does not plan to fully emulate PCI and PCIe bus any longer, so we write the PCI bridge driver in the VM. We already submitted the code. It is in code review phase, and this page I marked here, it implements a PCI bridge driver to talk with the host to identify the devices, allocate resources, will create the encryption, and also cover how to end and how to move. So that's the concept. Let's see a demo. I will show you how we dismount the device from the host. Then later this device can be used for the virtual machine. Then I will hot end this device to the virtual machine and configure it and use a performance test to show that. After that, later will also remove it. Since we need Windows Server 2016, so I have to connect to my machine in our lab. Okay, I already run the script I just mentioned. You could get some ideas here. You will show it represent information such as this is an over-the-style PCI device, so that cannot be assigned. Okay, well, also next is traffic from this device may be redirected to other devices. That means it against the ACS. Okay, good. We have one device, Mellanox collects X3. It says it can be assigned. Then let us start from this device. Firstly, I need to disable this device from the host. So let me open the device manager. Okay. Let me find this device, system device. Okay, let me find the Mellanox. Okay, here you are. Then I needed to disable it. Okay. And by the way, we will need the information of this device location path. So I need to find the location path. It was so printed in the script, but later we also found that here, and let me copy that because I will need that. Okay, this one. Copy. Okay, so we already disabled this device, then also dismount it from our host. Then you will need a location path. It takes minutes, maybe seconds. Oh, it prints the error. Oh, that's why. And that is what I wanted to mention. If we go back to the information, you will notice that it marked it can be a then, but it is interrupt. Interrupts are message based. Sometimes the script will check all those things, but for some devices, it can be enforced to be ended. Let me try and one first. Okay. And let me check whether it is there. Oh, okay. So now it is dismounted from the host, then VM can use that. I have VM is running. I will use this one based on FreeBSD head. And let me see whether this device has any available device. Nothing. Then let me add this device to him. Again, we need location path. Need to copy that, okay? Okay, need to see that again whether I have it. Okay, here you are. Let me open this one. This is Hyper-V Manager. And we could see all of which machines are here. This is mine. Okay, you could see Mellanox PCIe networking adapter is added. Let me use PuTTY, connect it, and then I could have a big window here. Okay. Okay, you could see we have two Mellanox ports here. Let me use one node port and give him address. Okay. Okay, before I test the performance, I also wanted to show more information here. After we added this PCI device, and you could see information from the, okay, my mouse isn't. Okay, here you are. The last one is Mellanox PCI device. So you could see that now. And the last was so. And you could see detailed device information. Where it is. Let me see. Okay, here you are. You could see a PCI bridge is created and mallocs interrupting information and memory information here. Okay, then let us have a test. I already set up another physical machine in my lab. This is the networking topology. I have a bare metal machine in my lab. The IP address is 0.22, and I just gave my malloc port the IP address as 0.11, and then let us see how about the throughput between them. Open another window, and we can compare that. We use iPath. We just wrap up it, and then we could to add the parameter how many threads will be used here. Let's test 3 seconds here, and as I mentioned, let's try 8 threads. By default, my FreeBSD virtual machine acts as a sender. Then here you are, you could see the number. It is about 37 gigabits for the throughput. Oh, that's nice. Let us see how about the receive side. I just keep this test running 30 seconds, so the data is a bit not stable. Okay, so as for the receive side, you also can see the throughput is about 36 gigabits now. Oh, it works. So that is what we did, and we was upstreamed. Then let me try how to remove this device. Okay. Just remove VM available device, VM name. Do I need to copy that again? And you could see some system message here. Yeah, it's detached. Then let us go back. Fconfig, check that again. Oh, so no mallocs networking adapter here. And then let me check PCI. Conf again. Okay. Last time we got the last one shows as malloc PCI device, so it also disappeared. Okay, so this is hot mode. And if we want to get it back to the host, we just need to mount this device. Let's try see VM host. We removed this device from my virtual machine, but it is still in the pool for the virtual machine. So we need to mount this device back. Okay, let us have a check. Host, then about device. Okay, so it is back to the host. Then let us go back to the host device manager and scroll down to find the Mallox device again. Okay, here you are, but the status here is still disabled. Then we label that. Okay, then we give that back to the host. Okay, that's my demo. So I got one PCI device from host, how to add that to my virtual machine, and test it with my bare metal machine and get a very good performance. And I also tried how to move it and restore it back to the host. That is the work we have done by law. As for the next step, during the performance testing, we also found out it seems hyper-width scheduling can affect the performance effectively. We still need to identify the why, so that is one thing we need to put some effort, and we will implement the SIOA for FreeBSD virtual machine. And we also shared this feature to our ISV vendors. Some of them showed interest, so we plan to integrate it to their products. If you have any interest to integrate those drivers to your product, you could contact us. I talked about PCI Passthrough and Hyperway. Let me also give you two examples about the PCI Passthrough in Microsoft Azure. I'm not sure how many of you know Azure, so I just use one page to introduce Azure. Azure is the cloud computing platform hosted by Microsoft. It is hyperscale. We have about 34 data centers worldwide, which is more than the total number of Amazon AWS and Google computing engine platform. We provide Azure for public cloud. We also have Azure Stack for private cloud. The architecture of Azure and Azure Stack are consistent. That means you could bring any workload to anywhere, which was build the hybrid cloud. And for Azure, about more than 80% of Fortune 500 companies are using our cloud. So that is enterprise proven. Here, today, I would like to highlight our cloud platform is open and flexible from the top to down. From the including, if we are talking about infrastructure, it includes Linux, FreeBSD, and OpenBSD is also coming. And we have Hadoop, Redis, MySQL, MongoDB in database level, and have Java, PHP in app framework. We also integrate Cloud Foundry on OpenShift to provide the application management service. And we also support Chief Puppet, the NetJS Vagrant. It was so introduced yesterday for DevOps and management. We're happy if you have any open source based solution and want to enable that in the cloud, you could come to us. So that is Azure. Per the strong customer requirement, and we also have two case studies about the PCI pass-through in Azure. One is GPU direct access. We published the unserviced virtual machines that enable the NVIDIA GPU. Then you could directly access the GPU and to run your accelerated workload. So far, both Windows and the Linux virtual machines are supported. It is in public review now. No BSD OS in the pipeline so far. But if you have any customer request, you could stop to us, then we could see how to add it into the pipeline. The second example is about the networking. This year, September, we also announced the accelerated networking. It enables SIOA. So far, it only supports Windows, but Linux is on the roadmap. Again, if you have any request for BSD, then let us discuss that. It is also in preview. Okay, so that's two examples. And as for the BSD, we enabled BSD-based virtual appliance in Azure Marketplace, including Citrix, NetGate, Padre, Array, and ILO NetApp. Currently, they are in beta phase, and they also will officially publish their image in Azure Marketplace maybe later of this month or that. We also expect to work with more virtual appliance vendors to bring your workload in Azure Marketplace. Besides BSD-based virtual appliance, we also published the FreeBSD 10.3 this June in global Azure and in Azure China this September. As I mentioned before, OpenBSD is upcoming. We are working with Estanara, whose product is based on OpenBSD. They will supported our FreeBSD integration service to OpenBSD. When I say this, I want to show our portal to you. Okay, this is the portal of Azure. When I see we published the FreeBSD 10.3. That means if you have Azure account, you could just go there and search FreeBSD. Then you could get the image. You need not to do anything, just follow the steps to create it. You are required to fill some information such as the name, the SSH key, or something like that. After you created this virtual machine, FreeBSD 10.3 is running in Azure. You just need to remote access that and control that or set up any workload. Welcome to try it. If you don't have Azure account, but want to have a try, you also could stop by me and let me see whether I could help you to get an MSDN account or not. Okay, so that's all I have today. Any question? By the way, as I mentioned, I have our developer Dexuan on the phone, so he is also happy to answer any question you have, and I also bring the gift for any question. Yeah.
I was just curious, after you got the pass-through working, how much of a performance improvement there was?
After PCI pass-through?
Yeah.
Okay. Before, without PCI pass-through, the networking throughput we got is around 27 gigabits. So with PCI pass-through, you could see for 40 gigabits networking adapter, we could get near to 38, 37 like that gigabits. So yes, it is dramatically improved.
Okay.
Thank you. Any other question? Okay, if not, I want. Yeah.
So I noticed one of the people on there was Sefi, and I know he also works on the Dragonfly project. And I was just curious if, in addition to OpenBSD coming soon to Azure, if there's plans to potentially support Dragonfly soon?
If any customer request, yes. In fact, anything is driven by customer needs. Even for PCI pass-through, in fact, Microsoft started to work on SROA since year 2009. But we did not enable this feature officially in our product because no strong customer requirement. But since Windows Server 2012, we got many customer requests, especially for GPU pass-through, be frankly. So we started to enable this feature in latest Windows Server, and we also get it running in Azure. So if any customer request for Dragonfly BSD or any other BSD, yeah, definitely we could work together to make it happen. Yeah. Even for, we also are working with Delphix. Their product is based on Enormous. Yeah, they have customers to request that, so we also are working with them to see how to bring that to Azure. Okay.
Thank you very much.
Thank you, and could I have 1 more minute for this? Yeah, again, yes, thank you everybody for my topic here, and again, we plan to host the BSD meetup. If you know anybody in China who has any interest for BSD, please share this information to them and welcome join us. Thank you everybody.